Okay. So a quick introduction of Nick. Nick Webber is the Acting Director of the Scientific Computing Services at the National Institutes of Health. For the last 13 years, he has supported the cloud computing, high-performance computing, and other research-enabling scientific infrastructure at the NIH. Currently, Nick leads the NIH Science and Technology Research Infrastructure for Discovery, Experimentation, and Sustainability, the NIH STRIVE initiative. So he's here today to tell us more about that.
Thank you so much, Rolanda. Appreciate you having us here today. I have a few of my colleagues on, and I see colleagues from Fogarty International Center, including Laura Povlich, so thanks for joining. I will share my screen, and as I'm doing that, I'll just go over a few quick logistics, so feel free to interrupt with questions, other things. The presentation is not that long. We wanted to leave plenty of time for discussion as well as for a demo. You can use the chat, and we have colleagues who are in the meeting who can answer questions in the chat or surface them as well as if you'd like. So with that, I'm happy to dive in. Just a quick check. You can hear me, see my screen in full screen mode. Is that correct? Thank you. Awesome. Well, my colleague, Dr. Kyle O'Connell, is here and will be helping with some of the demo and questions. But we wanted to talk with you about a couple of pathways to the cloud that DSI Africa members, research awardees, institutions can take advantage of today. So I'll first provide a little bit of background and then go into those two options. So first, I think this is something that all research programs are becoming more acutely aware of, is just the size, the amount, the variety of data in our research is becoming more and more intensive, and we need to have data and compute intensive capabilities to be able to work with those. And that's largely driven us toward cloud computing technologies, where we can get access to that level of computational capability on demand through the large cloud service providers. But you see here a quote from our current acting director, Dr. Larry Tabak, about partnering with academic and innovation industry partners, really to create this biomedical research ecosystem that allows us to advance biomedical research in ways that we couldn't do before, including putting all these different types of data together, different research program data sets together in this ecosystem to both ask and answer new research questions. So this is something NIH has heavily invested in over the past probably 5 to 10 years. And I'll use this slide here from Dr. Anthony Philippakis from the Broad Institute. But the data sharing model over the past decade or so has really inverted. So the old way would be to bring data to researchers or send data to collaborators, which would involve copies of data, challenges with accessibility and maintaining versioning of data. And that has largely changed in the recent past, where now we are bringing researchers to data instead of the other way around. So if you have a public cloud environment, you can bring researchers, tools, other things to that central data set, the true source of truth, and be able to have additional accessibility and elasticity to kind of work on that data set in collaboration with others, as opposed to independently in the former model. So we see a lot of benefits to cloud computing. So you see the opportunities there on the left. It's easy to spin things up in a prototype fashion, shut them down, do kind of more experimentation like we do in laboratory studies. It makes it so that we can get access to the latest and greatest tools and capabilities, for example, in artificial intelligence, machine learning, deep learning. And it really democratizes access to scientific data and computational resources. So no more do you have to have local on-premises computational resources and support. You can get that on demand in the cloud with a network connection to be able to get to one of these cloud service provider platforms. But it's not just all just positives. There are still challenges in getting to the cloud, as I'm sure many of you are aware. So one, being able to pay for cloud. It's a different model. You pay as you go. It's not kind of an upfront investment that you can just leverage. Adds complexity. Sometimes security protections are difficult or unclear. How do I make sure that this is appropriately secured in the cloud? Costs are another question. If you don't know how much it's going to cost a priori, budgeting for that and making sure that you don't run through more of a budget than you assumed is another challenge. And it's a different way of working and a different way of computing and collaborating. So there's a training deficit where people may not necessarily have the skills right now to be able to do it without taking some training or having some experience and exposure to these technologies. And so NIH has two cloud programs that can help address the challenges that I just mentioned on the previous slide. And I'll talk through both of them in a little bit of detail today. So the first one is called the NIH STRIDES Initiative. That's what Rolando mentioned, the Science and Technology Research Infrastructure for Discovery, Experimentation, and Sustainability. And this is a pathway for researchers and research institutions, as well as research consortia, to get access to cloud computing platforms, cost discounts, and other benefits. And I'll show in the next few slides that we've had a lot of uptake of this from research institutions, both domestically and some international use cases, including in Africa for other programs. We also have something that we are just releasing called the NIH Cloud Lab. And this is a kind of sandbox, try before you buy test bed area for people to kind of get a feel for what the cloud is like, the interfaces, the consoles, the tools, working with public data sets. And this is really meant to allow people to, again, try before they buy with some support and subsidy funds. So this is no cost to end users. It's subsidized by our Office of Data Science Strategy to allow people to come in, try out cloud tools and technologies, run through some tutorials for a time delimited, generally 90 days, and dollar delimited, generally $500, kind of duration. To be able to get a feel for whether cloud is right for them. And then the ultimate path might be, okay, I tried things out in the Cloud Lab, I'm very interested in continuing to use the cloud. Let me enroll in the STRIDES initiative, and we'll talk through that kind of pipeline today. Additionally, my colleague Kyle will walk through an example of using the Cloud Lab to do biomedical research in the cloud, following some tutorials and videos that we've put together for the broad community. So the STRIDES initiative, I mentioned some of this before, but really it's about allowing NIH researchers and NIH-funded researchers, including you all at DSI Africa, to get access to cloud computing tools and technologies in a more facile manner to accelerate the path to discovery. And so we've negotiated with cloud providers to reduce costs, so you're not paying market rates and the financial obstacle is lowered. Additionally, we've streamlined the onboarding process and have some training programs and other training content to allow this to be, again, a much easier process than if you were to go at this alone. There's still challenges, as we mentioned before, but as we discussed, the motivations here are to democratize access, anyone with a good idea, and the wherewithal to want to pursue that idea should be able to get access to the latest and greatest tools and technologies that exist in the world today to be able to act on that idea. And that's really a driving factor for STRIDES. And then we do want to make sure that there's cost savings and other benefits to the research community through these partnerships with Amazon Web Services, Google Cloud, and Microsoft Azure. And we have partnerships with all three. We have lots of research programs using all three of these cloud platforms. So one of my colleagues, Dr. Susan Gregorick, the director of the Office of Data Science Strategy, likes to describe kind of data as the new oil, something of value, a commodity that you can kind of trade and reuse and repurpose. And I like that analogy because it can really show the benefit of making sure that we have findable, accessible, interoperable, and reusable data sets, FAIR, I'm sure you've heard that acronym, to really advance the biomedical research community. And so data types that we have supported through the STRIDES initiative include all of those that you see here, including more. So cloud computing isn't necessarily specific to well, there's only tools for genomic data analysis, and I'm working on imaging or something else. There's really a lot of variety in the types of research and the domains of research that people are pursuing in the cloud and via STRIDES. So, one of the examples that we always like to provide is, okay, so what? You're providing access to cloud computing capabilities. That's all well and good, but what's the end goal? And really, why we do this is because we want to help researchers have an impact on the research that they're doing, find therapeutics faster, or come to discoveries faster. So we think, again, with the democratization, with the collaboration, with the ability to scale and share in the cloud, that can happen. And here are some examples. You can see the publications with their digital object identifiers there for a few programs: Smart Scope, Elastic Blast, and the Anvil, which is a research ecosystem supported by the National Human Genome Research Institute, or NHGRI, there, that are all leveraging strides for advancing their research. And then on the right, we have a call out of something from our National Institute on Aging, NIA. And this is the Center for Alzheimer's and Related Dementias. And you can see the various examples that they're using the cloud for, kind of broadly, to make data, make their code and tools available in the cloud, kind of share and showcase what they're doing in the research through strides and cloud websites or portals that they've developed, and also provide training content for people to come and use to be able to interact with data that they've hosted in the cloud. So again, there's lots of different approaches that people can take and have taken, and we like to make sure we're doing whatever we can to support the scientific endeavor that the researchers are going through. So I'm not going to spend much time on these next two slides, but you can just kind of see examples of the research institutions that are currently participating in strides. Some may be partner institutions for your awards, as well as some of the major research programs that NIH funds or conducts in our intramural program that have taken advantage of the strides initiative. Again, some of the largest and most notable NIH programs you'll likely see here. So in terms of value, we talk about kind of the pricing that's lower than market rates. We talk about access to training and other things. There's also support, which is an incredibly important piece to the Strides initiative, directly from the cloud service providers, from the Strides team here at NIH, to be able to get help and figure out, how do I do this? How do I build this? Is this a new way that I want to share with the research community? And that's definitely been a benefit to the Strides initiative, including through additional partners. So some of you may be familiar with the cloud providers. They have a marketplace associated with them where you can get access to third-party tools and technologies. Some of these are data-intensive kind of platforms like a Databricks or a Snowflake, or a host of others in that space that may be beneficial to your research as well. So you're not starting from scratch, you're starting at the platform level, but still using the Strides initiative to get there. And on the right, you can see the impact to date. The program's been around since essentially the beginning of 2019. So we're in our 5th year. And you can see the amount of data and computational hours conducted on the cloud through Strides, the number of research programs that have signed up, cost savings to NIH based on the negotiated discounts, and our training program is now 5,300 strong. And one of the things I like to point out on this slide, if people aren't kind of familiar with size and scale of data, for example, 1 petabyte is the equivalent of 20 million 4-drawer filing cabinets full of text for 1 petabyte. So you can see here with nearly 250 petabytes of data in the cloud, that brings kind of a capacity and a scale to research that, again, is not possible on a local workstation, and in many cases not even possible on local high-performance computing environments that cannot scale to this level of data and computation. So how do we participate in Strides if you're interested? We essentially have this 4-step process and ways to get help through our Strides partners. So first, it's selecting a cloud service provider. Again, we have 3, and if you aren't certain, you can try out the Cloud Lab and see which one makes the most sense, or we can connect you with them and you can talk with them. But essentially, you work with the cloud service provider and their billing and administrative partner. You can see there on the right the email addresses to contact, and they'll assist you in getting kind of the right orientation to be able to take advantage of those cloud platforms through Strides. The next step is an important one to consider for research programs. It's really the funding pathway. How are we going to pay for this? Essentially, there's two core paths to do this. The first one is NIH can be invoiced. And we talk about invoicing, and essentially that's just paying the cloud consumption bill at the end of the month. Research programs rack up a bill, and somebody ends up paying for that bill. So it could be NIH. This is what we call the in-kind or supplemental approach. We've had many research programs take this approach where instead of providing maybe grant supplements to an awardee institution to pay for their cloud services, the funding institute or center here at NIH will put money on the Strides Award and say, this research program is able to draw down on those funds, for their work. So again, it's kind of in kind, rather than a direct funding mechanism. The second path, again, heavily used, is what we call awardee invoiced, and that's where the institution that you represent, where you get your grant funding from NIH for your programs, that institution has a payment relationship with the cloud service provider, referencing Strides and the Strides discounts, and you can use grant funds for your research to be able to pay for your cloud computing costs. And importantly, for research consortia, and I know DSI Africa has a number of different research institutions and programs associated with it, there are also paths to set up Strides through a consortium model where instead of each institution enrolling in Strides and setting up that payment relationship, it can all be funneled through one if you have kind of a cores for data for data coordination, data management. You might use those core awards and institutions to manage access to Strides as well, and we can work with you on that model if that's of interest. Ultimately, if you decided number two, your funding pathway, we have a kind of an account request process and form to make sure we understand what do you need, how can we deliver those accounts to you in the cloud. We capture contact information and other things to make sure we can keep you up to date on anything that's new or changing. And then finally, number four, you're essentially up and running in the cloud. You can get help from the cloud service providers to kind of set up and maintain your cloud infrastructure and resources, and make sure that you have the right settings and permissions in place to be able to say, okay, this research program has this access over here, and that research program has a separate set of projects or resources that you have access to. And again, we can work with you through that if you are interested in pursuing Strides enrollment. And then a couple of examples here, specifically NIAID, our Allergy and Infectious Diseases Institute, does a lot of international work in China, in Europe, as well as in Africa. And here are a number of activities that they have supported through the Strides initiative, including international research components, most of these specifically in Africa. So the first one is the GLOBE program, Global Laboratory of Operations Biomedical Exchange. Essentially, it's a virtual research organization with lots of scientists and institutions involved. So again, this is kind of a consortium model that I described before. We can put you in touch with the folks at NIAID who have set this up if you're interested and you want to know the ins and outs of how did we do that internationally and what are some of the policy considerations and other things for working in another country as opposed to using cloud services here in the US. There are additional specimen management programs, kind of survey and clinical information gathering programs, as you can see there, the third bullet, as well as data management systems across multiple centers and many data sources. So again, I can imagine maybe some of your programs have similar components to one or maybe even more of these. And again, we'd be happy to put you in touch with the folks there. You may already have relationships with that group at NIAID to potentially learn more. So the second part here is, okay, I'm intrigued, but I'm not sure exactly if cloud is going to be right for me, if it's going to work, how it's going to work, or which cloud provider I might want to use. And that's where kind of Cloud Lab comes in to try things out before you actually kind of jump in with both feet. So Cloud Lab is meant to allow researchers to experiment for a limited time and in a cost-controlled fashion within an environment that's low risk. And what I mean by that is, we have it set up so that there are security guardrails. There are certain things that make it so that data can't be kind of broadly exposed, or other settings can't be made that would result in runaway costs or potential security vulnerabilities in those environments. And so we have these Cloud Lab platforms. Internally to NIH, we have all three, AWS, Google, and Microsoft. Externally, we only have two right now. We're working on the third. So we have AWS and Google available to what we call our extramural awardees. So those that NIH funds, like the DSI Africa programs. And you can see on the right the number of use cases. These aren't exhaustive, but some people use the Cloud Lab to test out, are these tools right for me? How much is it going to cost to do, kind of maybe a unit level of analysis to budget for, your total experiment or your total research project based on what you can find at a small scale. To develop new tools or share ideas, opportunities to collaborate and work with others, as well as to learn new skills or apply skills that you may have learned in a training program. And Kyle will walk through this here in a moment to kind of see how you'll learn as you go through tutorials and video examples that we and our collaborators have provided available to the public on GitHub to be able to really, again, practically learn as you go, working with real data and real biomedical use cases. So a few things just about Cloud Lab, what it is and what it isn't. So as you can see on the left, it's really meant for testing and trying things out. It's not meant for kind of production grade research. So this isn't meant to be a long-term location for research programs doing kind of their research at scale. Additionally, it's available for those who are interested in cloud. You don't have to be somebody using Strides, for example. You can try it out as a pathway, as I mentioned earlier, to potentially enroll in Strides if that's right for you. It's not for sensitive data. You can bring in your data, and public data sets are accessible, and Kyle will demonstrate that. But it's not really meant for PII, PHI, other things, again, because it's a short-term test bed, not a long-term kind of research grade environment for you. Additionally, NIH, as I mentioned, we have the security guardrails, the cost enforcements, the other things there. So your institution doesn't need to manage that. That can often be, a benefit to those getting started. But we can also work with your institutions if they are interested in understanding how this works, to share how we've set this up so that if they want to replicate some of that to support you, maybe in a full-scale Strides cloud usage situation, they could do that. And then, as you see on the right, you have full access to the cloud consoles. So this isn't really a kind of toy environment. It's really access to all the cloud can do in the the consoles that are there. So you can get access to CPUs and GPUs. You can work with managed Jupyter notebooks and try out the latest and greatest AI and ML capabilities, and a host of other things here, again, that you can leverage. So here's a vision for Cloud Lab that we've partnered with the National Institute on General Medical Sciences, NIGMS, to establish the initial framework for. And essentially, NIGMS had research awardees at these institutions in the United States. And they're specifically at institutions that are known as IDEA states, which are essentially states that receive less funding, have historically less access to large-scale data and computationally intensive research than the other states in the US. So you'll notice places like New York and Boston and California, those places are not listed here. It's really, again, those states that have fewer resources and don't have as many, kind of researchers or research institutions working in this area. And this is that democratization piece that I mentioned. So we're working with those groups, and we have supported providing, which Kyle will show, tutorials in each of these areas. So they had research, I'll pick one here. So University of Rhode Island, they're in the middle for biomarker discovery. They already were doing research and creating workflows and pipelines to support and teach about biomarker discovery. We worked with them to essentially take that from on-premises and move it to the cloud and make tutorials and videos to allow people to do that through the cloud lab or through other means, to again get broader access to doing that sort of work. And so we see this as a model of recycling existing knowledge and adding additional tutorials and building a compendium of resources to allow people to try out research in all sorts of different domains. So you see 12 of them here. Hopefully a year from now, we have 50 examples of research institutions, primary work that they've essentially provided a template to do in the cloud. And you might imagine, instead of a map of the United States, maybe this is a map of Africa and countries that are participating in doing something like this as well. If DSI Africa were interested in replicating something like this that NIGMS did for its IDEA program. And then, these are just quick examples of the modules. So again, they're on GitHub, publicly accessible, walkthrough guides, step by step, here's what you need to do, as well as videos on YouTube, publicly accessible. Very interestingly, a lot of these have, kind of the components of teaching the science in addition to using the technology in the cloud. So they walk through the basics and understanding why are we doing this? What is the scientific discipline? What's the underlying kind of knowledge that's being kind of applied here about life sciences? And there are interactive tutorials and quizzes and other things as part of these. So those research institutions I showed on the last slide really did a good job of saying, not only do we want to allow people to try these things out in the cloud, but we want to teach the science. We want to know, let people know, here's how you can do ATAC-seq at scale, or as I mentioned, biomarker discovery or metagenomics, or a host of other capabilities that are being provided. So definitely encourage you to check these out. Even if you're not planning to use the cloud, you can still learn from the tutorials and the videos if that's of interest. Here are links. We'll send these slides out, but here are links to these resources. The Cloud Lab repositories of tutorials and walkthrough guides and videos. On Google, you see two examples here. One is the Google examples for Cloud Lab, but the other one is specifically those NIGMS sandbox modules from the 12 institutions from a couple slides ago that also have links to YouTube videos and other research support modules to be able to help people work in this space. And then lastly, we'll kind of wrap up here to share that if you're interested in this space, you can explore our content, see if that's something that you may want to sink your teeth into or even add contributions to. It's meant to be kind of a community resource. You can express interest in Cloud Lab if this is something that you'd like to try out. There are some limitations right now to Cloud Lab in that we are partnering with the In Common, which is sort of like EduGain in the international community. We have In Common here domestically to allow research institutions to federate their logins, use their home institution username, password, and credentials to log into the Cloud Lab. Within the next, probably certainly within a month, we will have broader generic access, and that may be more accessible to many of you if your institutions aren't participating in those federation organizations, that would allow you to still use the Cloud Lab using a trusted and known identity, typically from something that we have here in the US called login.gov. I believe anyone can use that. We'll have to double check to make sure it's fully available internationally, but there are other pathways that we're exploring that we know are internationally supported, like ID.me, that may be a path for you all as well. And then lastly, anyone interested in enrolling in Strides, again, there's a pathway to do that. We provided that 4-step process. You can work with your research institution and our cloud partner providers, or you can kind of coordinate internally for that consortium model that I mentioned, to make it so that individual research institutions don't have to enroll, but instead the DSI Africa program enrolls on behalf research institutions and researchers if that's of interest to your community. So with that, I'm going to leave it on this slide, and we will gladly take any questions or comments as we prepare to transition to Kyle for his demo. So let's pause for questions or comments.
Hi, I have a question if that's okay.
Sure.
So this is Stephen Wong. I'm part of the AgriCon University. We're currently on Azure, but are interested in the STRIDES program. My question to you is there any constraints as to which geographic location we set up the environment? Because we have some strict policies where we're limited to certain geographies where we can set these up. So just want to know if there's any limitations to that.
Yeah, and glad you asked that question. So the STRIDES awards are written such that, you know, the general expectation is that the infrastructure, the data centers that the cloud service providers have are located in the continental United States. However, we do have programs like that NIAID, set of programs in Africa that have, that have approved exceptions. There we go to that general expectation. There is a process that you can go through. Essentially, it's with your kind of funding institution here at NIH to make sure that things are appropriately documented in systems that we have for the U.S. government. So there's one called FACS. It's part of the State Department system. You may already have information in there if you're working internationally with NIH funding. But through that, you can then kind of add to your terms of award an expectation or an explicit reference to this research program will be taking advantage of the STRIDES initiative. It will be using Azure infrastructure in this region of the globe, outside of the continental United States. But we just have to have that kind of documented and our I's dotted and T's crossed to kind of get away from the default, which is the US based data centers. But it is possible, and we do have people doing that today.
Okay, that's great. Thank you very much.
Welcome. Any other questions? All right, well, then let's take the opportunity to turn it over to Dr. O'Connell.
We do have a question in the chat, Nick. It says, is there a cost associated with using the cloud infrastructure?
Yeah, great question. So yes, for STRIDES, for the standard setup, there is cost. You run up that cost based on usage, and I mentioned there's either an NIH invoiced approach or an awardee institution invoiced approach that we support that can pay for those costs. Now in Cloud Lab, no cost to the end user researcher. However, Cloud Lab is meant to be short duration and small scale, so you can get essentially $500. We have had those who said I need a little bit more to really be able to understand, and we've been able to kind of make exceptions to have a second 500, not 10 of those, right? But maybe a re-up. But beyond Cloud Lab, either the research institution or the NIH funding institute or center rather would be paying for those costs, albeit at a discount that we've negotiated for STRIDES.
Well, we'll say on the subject of costs, and I can show this in the demo a little bit, but it is it's a mentality switch when you're used to using HPC on-prem, like SSHing into a cluster or just using a desktop or a laptop. It's a different mentality of spinning up virtual machines and spinning them down. And a lot of times at the beginning, it's hard to remember to spin things down. Or sometimes people, if you use a service you're not familiar with, there can be costs you're just not as ready for. So we try to do a lot of education to try to prepare people for managing those costs, how to manage budgets, set up budget alerts, create safeguards so that you don't, because you could spend a lot of money very quickly, but also if you're smart about it, it can be very cost effective. So that's a lot of the educating that we do. But I will show how we have some things set up here. And if you have any questions, feel free to just throw them in the chat. And when I finish, we can have more Q&A. Okay. All right. So the way that we have this Cloud Lab program set up is that people request access to one of the 3 cloud providers. So they can have Google Cloud. I have AWS opened here as well. So they can have access to AWS, or you mentioned Azure as well. So we give access to the Azure portal. So they get access to one of these portals, and then they also have access to these GitHub repositories, which we've actually made public. So everyone has access to these GitHub repositories. And we have a GitHub repository for each of the 3 cloud providers, which is kind of where I'll start here. So since that whole NIGMS program is in Google predominantly, I'm mostly going to show you Google Cloud here, but it's basically replicated across the 3 big cloud providers in the US. So we have this kind of how-to guide of like basic skills that we think people need to learn. And we've been iterating on this over time as we've had users, but it's like how to use Google Cloud Storage and how to use virtual machines, things like that. So, and there's links to other NIH resources or resources from the cloud providers or little tutorials that we've built about how to do some of these basic things. Like you could see, we follow this link to how to spin up a virtual machine in a Jupyter notebook. It has kind of this guide with screenshots. So that's one piece of these GitHub repositories. The other is these tutorial pages. And here we've collated a lot of public tutorials and then built a bunch of tutorials in-house for each cloud provider. And we've taken use cases that we think our community would be interested in. So like a general biomedical data science workflow, how would you run things? What are the different ways you could run analyses in Google Cloud? And then here's medical imaging, machine learning, downloading data from the sequence read archive from NCBI at the NIH, variant calling, things like that. So try to give different examples of how you could do these different use cases. And this is one area that we'd love to collaborate with other research groups. If there's things that if DSI Africa got involved in this program in strides generally, we could build out tutorials and collaborate on adding additional content to this page. So that's kind of general Cloud Lab. And then, like Nick mentioned, we've collaborated with NIGMS, where we built out this NIGMS sandbox program. And there was, man, please pause in one moment. Sorry, I hid my thing. 1 second. I have a screaming child. One moment. All right, sorry about that. Working from home. All right, so we built these 12 modules with them, and each of them, like Nick said, has a different use case. And so they have separate GitHub repositories for each of these. So we have kind of this main landing page. We've been building out different learning pathways with these. So skills that we want users to learn, and then, kind of sorting these different modules by topic. And then if we go to each of them, they have their own repository here with all of the Jupyter notebooks within them, each of which is considered a submodule, and then kind of some background on the science and like what we expect the users to learn. So this is very introductory level, but it's very science forward. So the other repositories tend to focus a little more on the cloud skills, and these are kind of all about the science of the given module. And so the reason that we put this on GitHub is, one, they're easy to access publicly, and you can mix and match text and tutorials and code, but also we can clone them. So we can just copy this URL here, and within any of these cloud providers, you can open a terminal. So I've spun up a virtual machine here. This is Google's Jupyter notebook instance. So it's a virtual machine with Jupyter Lab pre-installed. I've created a virtual machine here, and you can customize, the number of CPUs, you can attach GPUs, the amount of RAM you want. So you select different machine types. And of course, the bigger machine, the more powerful machine, the more expensive it is. So if you don't need a lot of CPUs, you can create a pretty cheap virtual machine, but you open it, I already have it open here. In the case of this one, we could just do like a git clone. We picked that random repository, and now I have it available here. So I've already cloned all these repos. And then we can go inside. We have access to these Jupyter notebooks. So I've already opened one of them here. And you can see the nice thing about Jupyter notebooks is that we can mix and match like images, we can have interactive videos, we can have scientific background, instructions, and then we have these code blocks. So this is called Markdown. And so we can install, here we're installing Conda or Mamba as a package manager. We can use pip install, we can install different Python dependencies, and we can also change the kernel here. So here we're using Python. We can also switch to R or something like a machine learning background with PySpark, PyTorch, TensorFlow, XGBoost. So Google manages all of these dependencies for us if we change the kernel, which is very nice. So if you're using R or Python, you can kind of switch back and forth. And then I have some errors here because I didn't load something correctly, but you can see users can walk through this notebook, and this one's using like FastQC for quality control, and then doing some trimming, and then mapping to a reference genome with Bowtie. There's these interactive quizzes that can be embedded, and then you can also embed other Python libraries like Interactive Genome Viewer, IGV. And so they can use a genome browser to interact with like how different reads have mapped in some of these tutorials. So a lot of cool interactive tools here. One other one that I'll highlight is this tutorial that we just put together using the NCBI metadata tables, which are hosted in BigQuery, and they're also in AWS Athena. So in either Google or in AWS, you can query all the data that's publicly stored in NCBI, and you can use SQL queries like this one from within a notebook or within the console. And I ran this a little bit ago. So here I'm searching for monkeypox. So you search for an NCBI taxonomy ID, and you can do a whole host of filtering. Like if you wanted to just look for a certain pathogen only in South Africa, assuming that data had been uploaded to NCBI, then you could filter, for a single country, date ranges, pathogen ID, and you can export it to a pandas data frame and then do a bunch of filtering here. So you can see this is monkeypox virus, top hits here like US and Russia, but there's tons of metadata associated here for that virus. So that's a pretty cool tool if you want to be able to filter, search all of SRA for a given set of accessions, and then just download those accessions based on a research question that you have. And then you can use different pandas filtering tools within the notebook to downsample that original data frame. So pretty cool tutorial we built to show people how to do that. And there are a whole host of other ones, which are all within here. This is that original GitHub repo. So we have a bunch here. Like I said, the same exact thing could be done this is the AWS version. It's kind of a mess in this particular repo, but here's the original AWS repository tutorials, notebooks. And we have a bunch of tutorials here, as well as links to like AWS specific things that Amazon has built. So that's how we have it organized. That's pretty much it for the demo. And at this point, I'd love to get some questions if you have additional questions. Or feel free to just put them in the chat. If you don't want to jump on.
Thanks, Kyle, for going through that. And hopefully folks can see that, again, this is the try before you buy Cloud Lab component. These tutorials to run an individual one cost somewhere between $2 and $10. So you have that $500 initial setup, so you can do a fair amount of learning and testing and applying with your own data sets. But then the anticipation is those who find this way of working these resources useful and valuable, you can potentially go through the process of that strides enrollment that we mentioned before. So we try to connect the two where we can to make sure you have long-term access to these technologies if that's going to be valuable to your research.
Hi, it's Stephen Wong again. I have another question for you about the Cloud Lab. Is it possible to mix and match? So if we're in Azure right now and continue with our environment in Azure, but we might be interested in some of the capabilities of some of the other ones like Google or AWS, could we try out the Cloud Lab in Google as an example, but still retain an Azure Stride subscription?
Yeah, so Kyle may be able to speak a little bit to how you would do that in, pulling the content from the repositories. They're not necessarily exclusive to a given cloud service provider platform. There are some exceptions where one might use SageMaker, which is an AWS specific tool that can be genericized, but a lot of these can be run in any computational environment. They can be run on-prem, they can be transitioned across cloud provider platforms, and as Kyle mentioned, we've done some of that work to replicate some of those tutorials across them. But yeah, in terms of your question, I think we do intend to have Azure Cloud Lab available, probably in the next 6 months. You are welcome to use the other Cloud Lab environments to kind of test things out, but also there's possibility to kind of expand or extend those tutorials to be able to work across CSPs as well, and we'd be happy to.
Right. So, but it is possible to test out multiple different cloud environments. So I could test Azure, I could test Google as an example.
Yes, you can.
Yeah. Okay. And just to follow up, I don't know if you mentioned it, but is there a time limit on how long we have access to the Cloud Lab?
Yeah, so typically it's 90 days and $500. As I mentioned, we do have some participants who've asked for kind of a second 90 days and second $500, either due to extenuating circumstances or because their use case isn't quite finished. So we have been able to provide that, but it's really not meant to be year-long or multi-year long sort of environment for you.
Right. Okay, that's great. Thank you. It's a great presentation.
I thought there was another hand up.
Hi, this is Brad from Fogarty. Wonderful presentation. This has been really, really good. And this is really a follow-on. I put my hand down because a lot of my question was answered from the Stephen question. But we have a pretty broad level of different knowledge levels regarding cloud across the DSI consortium. Some people are very, very knowledgeable, some less so. And how much would you say that these tutorials and learning opportunities are suited for purely very knowledgeable people in this area versus people that are more at an informed beginner level?
Yeah, I'll give that one to Kyle.
I mean, the intent is definitely that they're written for a more introductory level, and we want them to be the building blocks for people to get the basics and then go off and build their own thing. It's possible that I have some expert bias in some of the things that I wrote, that I'm too far along at this point, but especially the NIGMS ones are designed for undergrads particularly, and all of them we intend to be at a very introductory level. And we tried to, I will say that the CSPs, like if you go into Amazon or Google's documentation, you could just read for days and weeks of documentation. And so we tried to really condense all of that down to the absolute essentials. Like what is the bare minimum, or what are the essential ingredients that someone needs to get started? And then they can build on that. But we don't try to teach them everything under the sun, because you could go on forever.
No, that's really helpful, especially with we have people that are experts in this, but DSI is huge, and we've got a lot of earlier stage investigators and trainees as a part of DSI that I really hope that people start utilizing this as a training opportunity as well.
You just posted in the chat, Brad, too, that there are some on-demand training resources available as well. These are more for learning the cloud than learning how to do biomedical research in the cloud. But I provided a link there that has generally on-demand self-paced training that is either already available for free or through DSI. There are potentially pathways that we can work to set up training programs to allow researchers to kind of get that base level of 101 orientation, as well as kind of applying that to research use cases. We do have some biomedically specific training courses that we've offered.
Great
Nick,
resource. Thanks, Nick.
Can I just add something, Nick?
Sure.
It's bad. Yeah, so like, when you're talking about like from beginners to advanced, I do have to say that we've had a number of teams working to like stand up proof of concept, like workflows or pipelines. So we've seen some very advanced work in Cloud Lab, and they were just trying to make sure that it worked in the environment that they were trying to stand up. And then they would port that to, a permanent Strides account. So we have seen some very advanced like cryo EM work and things along that line. So it does, it starts, the tutorials we've built are kind of to walk people into Cloud Lab, but you do have the full resources of the Cloud Console. So you can do very sophisticated things within the Cloud Lab environment, even though you're cost constrained.
Great clarification. Thank you.
All right. Well, if there aren't further questions, I'll put in the chat again ways to get in touch with us. So, for example, there's our Cloud Lab email address. If you're specifically interested in Cloud Lab, I put that in there. And then our generic Strides email address. We try to make these simple, right? I put that in the chat as well. We do consultations all the time. We're happy to kind of talk with you about your specific use case. If you are interested in one cloud service provider over another, through Strides Initiative, we have and bring the expertise of the cloud service provider, kind of their partner support staff for Strides, as well as expertise on our immediate team in those environments. So we do encourage you to, kind of see what resources are there, contact us, and we can try to help. But I think, from my perspective, my guess is, the DSI Africa program, if you have groups that are interested in, potentially exploring or using the Cloud Lab and or Strides, it's really a matter of, kind of conversations with the NIH program staff as to whether, one, this would be something that the program staff would be willing to, kind of provide in-kind support for, versus they have expectations that the awardee, the existing grant funds would be used to pay. There would also be conversations around whether that consortium model that I referenced on behalf of the DSI Africa program may be a better path than, institution by institution enrollment. And then those questions that were raised about if you want to have infrastructure in international regions, perhaps located closer to where your research is, or your don't want to transfer data as far, all of those sort of things. There's some processes to go through to make sure that's kind of on the up and up when it comes to the actual grant terms and expectations for using outside of United States data center regions. So those would be a few things that I might recommend that you do if you are interested. Excellent. Thanks, Laura. Well, thank you again so much for having us. Rolanda, thank you for being such a great and organized host for this. It was super easy to work with you and through you. And we're happy to follow up, reach out to us. We will send the slides, and we wish you all the best in your research.
Thanks so much, Nick, and Council Andres Cooking. Thanks everybody for joining today.
Thanks.
Have a good day, further.